Hey, welcome back, Introstat students. Today we are going to do another exercise, and today we are doing what are we doing? We are doing writing hypothesis. Uh, I believe it's right here. No, writing hypothesis for a test about a population. Okay, so all right. So now, so maybe we can talk about a little bit about what hypothesis can be, right? What it should be. So let's erase all this and maybe put this somewhere. All right. So when you want to write a hypothesis, this is not working. Write a hypothesis. We usually put it as a null hypothesis, right? Null hypothesis. Now, what is a null hypothesis? And usually we denote it as H naught, right? HO. So, what is a null hypothesis? Null hypothesis, what the claim is, right? What is the claim? What is the claim? So, for example, if I'm standing on trial, right? So let's say, let me draw a box, and I'm standing on trial here, right? It's not a very good picture. Okay, so I'm standing there, and I'm trying to, so what's my claim, right? So someone is trying to defend for me, right? There's a prosecution, there's a defense. And my claim is I am not guilty, right? So the judicial system, right, for the U.S. System or policy is that you are innocent until proven guilty, right? So my first claim is that I am not guilty, right? Or I'm innocent. But typically they don't say that. You don't say I'm innocent when in the court the judge will not say we found the defendant is innocent. No, typically they say the defendant is not guilty. So the alternative hypothesis or alternate hypothesis is, right, what the claim is not. What the claim is not. And you got to read the context of the question. So here, I'm innocent. What's the opposite of innocent? I am guilty. Right? Or I am not innocent. So it's kind of like the opposite of your null hypothesis. Okay? So with that in mind, if we just jump in, Elliot read a report from a previous year saying that 6% of adults in his city bike to work. He wants to test whether this has changed. So he is going to take a random sample of adults in his city and see what percent of them bike to work. Let P represent the proportion of adults in Elliott City that bike to work. See this P? This P is actually the population proportion, right? The population proportion of adults in Elliott City that bike to work. So, in your null hypothesis, you will have P. It's the null hypothesis is always referring to the population parameter. So in this case, it's population proportion. It could be population mean, right? This is the symbol for population mean. So this is a symbol for population proportion. And we are claiming that The claim is the population proportion is 6%, so 0.06. So notice that the null hypothesis is always equals to, right? Always equals to. Now, it says here he wants to test whether this has changed. So your alternate hypothesis is that this has changed. Now, change how? Change more, change less? It did not say. It just says change. So if it's just change, we just put a not equals to 0.06. Okay? So if you look at what's given here, right, it's this, the alternate hypothesis is more than, we don't want that, so it's B, right? B seems to be the one that we need. Okay, right? So look at what the explanation says. This hypothesis use symbols for the population proportion P. We talked about that. And the direction of the alternative hypothesis not equals to, because he wants to test whether the proportion has changed, right? Did not say more, did not say less. So he's curious if the percent is higher or lower than 6%. So next question. A large poll showed that 42% of adults approved of their nation's prime minister. Margaret wants to test if this is now lower. So she takes a random sample of 1,000 adults in that nation and finds that 390 of them, or 39% of those sampled, approve of the prime minister. So let P represent the proportion of adults in this nation who approve of the prime minister. So the claim is, right, the null hypothesis is that the proportion is 0.42. Now, why am I not using the 39%? Because this 39% is actually came from the sample. So the P doesn't refer to the sample. You never test for sample. You test for the population parameter. So here, by the way, the sample proportion, we put a p hat on it, right? And that is equals to 0.39. So we're not putting this p hat here. We're just using p. And then the alternate hypothesis is what? Is it more than? Is it greater than? Is it not equals to? It says here that wanted to test if now it's lower. So we're going to test lower. So this is how this works, right? And which one is the actual answer? Right? Nope, this is not right. We got to pick something that is identical, but one is equals, one is lower. So I hope this makes sense. Let me know if you need, well, should I do one more? Let's do one more. Right, so here, a class did an experiment to see if students could taste water and identify bottled water versus tap water. Each student was presented with 3 cups of water, one of which contained bottled water, and they were directed to identify which cup they thought contained bottled water. The class wants to test if they correctly identify the bottled water significantly better than they would have done by just simply guessing. Now, if you were guessing out of the 3 cups, right? So if you have 3 cups, not. So you have to guess it correctly, you have a 1/3 chance of guessing it correct, right? Okay. So let P represent the proportion of the students that would correctly identify the bottled water. Okay. So the class wants to test if they could correctly identify. So the null hypothesis in this case, right? The null hypothesis is that, well, they can't correctly identify. So, and they're just guessing. Okay. All right. Now, 1/3 in this case, because we do not know exactly how many people could correctly identify the bottled water. We don't know that number. We don't know this population proportion. But we do know if everyone was guessing, right? So the population proportion, if everyone was guessing, will be 1/3. So the alternate hypothesis, is that if they're not guessing, it would be greater than 1/3, right? So here in this case, we are looking at P equals to 1/3 for the null and P is greater than 1/3 for the alternate. Okay, so here the null hypothesis has a statement of equality, right? That's why it's always equals to. And the direction of alternative hypothesis greater than matches their desired test if they correctly identify the bottom water significantly better than they would have done by guessing. So hopefully this help explains it. Let me know if you have any questions.